Example 6. An arithmetic sequence has A6 is equal to 9 and A15 is equal to negative 36. Determine A1. All right, I am going to solve this problem using two different methods, okay? You pick which method you like better, okay? All right, so in the first method, I am going to apply the very first formula we learned for computing the nth term of an arithmetic sequence, okay? That's an is equal to a1 plus n minus 1 times d, okay? All right, how can I use this here? Okay, I know information about the sixth term and I know information about the 15th term. Okay, so what I'm going to do here is basically apply this formula to both of these terms. Okay, so I'm going to start with A6. Okay, so for A6, that means n is 6. So go to this formula. Everywhere you see an n, pop in 6. So this is going to tell us that A6 is equal to A1 plus 6 minus 1 times D. Okay, so let's see. We know what A6 is, so we can plug that in. This is going to tell us that 9 is equal to A1 plus 5D. Okay, and remember what we're after here. We are trying to solve for A1. Okay, so I am going to solve this equation for A1. So I'm going to move the 5D over. We don't know what D is yet. Okay, so this tells us that A1 is 9 minus 5D. Okay, I am going to do the same thing for A15. Okay, I'm going to go to this blue equation and plug in n equals 15. Okay, so this is going to tell us that A15 is equal to A1 plus 15 minus 1 times D. Okay, we know A15 is negative 36. Okay, so this is going to tell us that negative 36 is A1 plus 15 minus 1 is 14 times D. Okay, again, we're going to solve for A1 here. Okay, so I'm going to subtract 14D from both sides. This tells me that A1 is equal to negative 36 minus 14D. Okay, all right, so if we carry on, where do I go from here? Okay, I need a specific number for A1, the first term. Okay, well, I know this is a way to compute A1, as is this. Okay, both of these formulas should give us A1. Okay, so what I'm going to do, since both of these represent A1, I'm going to equate them. Okay, so 9 minus 5D, since that represents A1, it should equal this other representation for A1. Okay, so this should equal negative 36 minus 14D. Now I have an equation that just has D. Okay, I'm going to be able to solve for the common difference here. Okay, so I'm going to get D by itself on one side of the equation. So I'm going to add 14D to both sides. This is going to tell me that 9 plus 9D is equal to negative 36. Move the 9 over. So I'm going to get 9D is equal to negative 45. This tells me that D, the common difference, is negative 5. Okay, so I know the D value. Okay, I can use this information to now go and get A1. Okay, if you look at either of these equations highlighted yellow, okay, since we know the D value, we can plug it in to get A1. Okay, so I'm going to come over here. Okay, I'll just use the first one. Okay, we know that A1 is 9 minus 5D. Okay, we just calculated that D is negative 5, so plug this in. A1 is going to be 9 minus 5 times negative 5. So A1 is going to be 9 plus 25. So that means the first term should be 34. Okay, so this was a way of calculating A1 using that original formula that we learned. Okay, so now I'm going to show you another way of solving for this. And it's probably going to be easier here. Okay, so I am going to use these alternate formulas. Okay, I'm keeping in mind, since I'm dealing with an arithmetic sequence, I want to think linear, I want to think slope. Okay, I'm going to use this guy. Okay, so when I look at this, okay, I'm thinking of A6 as the mth term, and I'm thinking of A15 as the nth term. Okay, so I know that I can get the common difference D by just doing the change in Y over the change in X. Okay, so I can do this. Okay, so I'm going to do, in the numerator, this is going to be A15 minus A6 all over 15 minus 6. Okay, all right, so we can just pop in these values. Okay, so let's see, A15 is negative 36. We're subtracting A6, which is 9. Okay, we're dividing by 15 minus 6. Okay, this is going to give us negative 45 over 9, which gives us the negative 5. Okay, we're getting this a lot quicker than we did with the first method. Okay, all right, so since we know the common difference here is negative 5, how can we proceed? Well, the end goal is getting a 1. So since I have D, I am going to return to the original formula because it has a 1 in it. All right, so to get the nth term, you need to take A1 and add n minus 1 times D. Okay, so what you can do at this point, okay, we're solving for A1. This is what we're looking for. We know the D value. The D value is negative 5, so we're going to plug that in. Okay, we're going to be solving for A1. We know two of the points. Okay, we know the 6th term, we know the 15th term. Pick one of them and plug it in. Okay, so like up here, I just said the nth term is A15. Okay, so we know that if n is 15, that means A15 is going to be negative 36. Plug this in. Okay, so I'm going to go ahead and say, I'm going to use A15 here. So A15 is equal to A1 plus 15 minus 1 times the common difference. Okay, this is going to tell us that negative 36 is equal to A1 plus 14 times negative 5. Okay, so this is going to tell us that negative 36 is equal to A1 minus 70. Add 70 to both sides. Okay, and this is another way we get that A1 is equal to 34. Okay, we arrive at the same answer. Okay, so it's up to you when you're doing a problem like this. You can use the original formula that we learned for the nth term of an arithmetic sequence, or you can use these alternate formulas to help you out. Okay, all right, let's take a look at example 7 at the top of page 6. Okay, here we are given the graph of an arithmetic sequence, and we are asked to write a formula for the nth term of the finite arithmetic sequence an shown in the graph. Then state the domain and range of the sequence, and here we're assuming that the entire sequence is shown. Okay, that matters for domain and range purposes. Okay, all right, as soon as you see the picture, you see the discrete points are falling along a line, so that means this is going to be an arithmetic sequence, and so it needs to have the format mx plus b. Okay, so again, the points make up the graph, not the entire line. However, you can kind of think about the entire line when you're trying to come up with the m and the b. Okay. All right, so basically all we have to do is come up with the slope of the line. Okay, so we're gonna have to just read the rise over the run off of the graph. Pay attention to the scale. Your x-axis is going by ones. Your y-axis is going by tens. Okay, so let's think about how we go from one point to the next. And let's look at the rise. You need to realize here this is a negatively sloped line, so the m value is going to be negative. Okay, so I'm going to do the rise first. I need to go down 2 units here, but that's really 20 units because you're going from 10 to negative 10. So this is down 20, and then you're going over 1 unit here, okay? So this is going to be negative 20, okay? We're not going to use x, okay? You have to use n for your sequence, okay? So negative 20 times n. So what about the b value? Okay, well, remember, what does a b value mean in terms of a line? Okay, well, it means the y-intercept, okay? So where would the y-intercept be here, okay? Well, let's just read it off the graph, okay? So I need to get back to the y-axis. Sequences do not start at 0, okay? Remember, the first term is it's n equals 1. You don't have n equals 0. But we have to backtrack and pretend n equals 0 just to get the y-intercept here, okay? So if there were a point on the y-axis, where would it be, okay? Well, we would have to go up 20, okay, and then over 1. So this would be up 20 over 1, okay? So if we're at 10 and we're going up 20, this would bring us right here. This would be the point 0, 30, okay? So the y-intercept here is going to be 30, okay? This is the formula for the nth term of the sequence, okay? And you can check it out to make sure that it works. For example, if I were looking at this term, okay, this is the 4th term in the sequence and its value is negative 50, okay? If you pop in if you pop in 4 here for n, okay, let's see what it would give you. It would give you negative 80 plus 30, which is negative 50. You know that's right, okay? So you can do little checks to make sure that you're right, okay? All right, so we've got the formula. Okay, now we need the domain and range. Again, we're making the assumption that the entire sequence is shown, meaning that the sequence does not continue forever. It is finite, only a countable number of terms. Okay, domain. Okay, that's tracking the number of terms. So we have the first term, the second term, the third term, the fourth term, and the fifth term. That's the domain. Okay, you're only dealing with the first 5 terms. You don't use interval notation here because we have discrete points. So you have to use the braces around your numbers. All right, the range, those are the outputs or the terms of the sequence. Okay, so again, use the proper notation. The first term in the sequence is 10. The second term is negative 10. The third term is negative 30. The fourth term is negative 50, and the last term is right here. It's negative 70. And that's it, okay? Knowing the characteristics of an arithmetic sequence made this a lot easier to do.